So I'm doing a short walkthrough here of the Tetris Generator saved map that I put together, just so folks can kind of understand what I did. I am going to have to enable debug mode here, just so that we lose the fog of war. I can zoom out and show you what we're doing. So number one is the 4-bit random number generator right here. So what I've got is two boxes, rooms, that are 3 tall, 4 wide, and they're separated by a door. I got my my dupe down here, Ruby. I get him to open the doors for me. And there's a critter sensor in each of the right-hand rooms of each of these. And if it's above 0, which means it's 1 or more, then we're going to turn that bit on. You can see that this is the new ribbon, 4-bit ribbon. And so the writer here is writing a 1, and he's writing a 1, and he's writing a 1. So this is in binary, bit 0, bit 1, bit 2, bit 3. On the writer there, 1, 2, 3, 4. So I'll try and remember to call them 1, 2, 3, 4, even though I think in binary in there 0, 1, 2, 3. And we'll see how far I get with that, okay? So the idea here is basically that you've got a fair system that randomly generates either a 0 or a 1 on each of these bits. You could theoretically stack these up as far as you wanted and make as many bit random number generator as you wanted to generate. Okay, so this writer is bit 1, bit 2, bit 3, bit 4. Okay, so if they're all off, that's a 0. If they're all on, that's a 15. That's binary to decimal conversion. So if 1 is on and the rest aren't, then it's 1. If 2, that's 2 by itself. 3 is these two together. And 4 by itself. 5, 6 is these two together. 7 is all 3 of these, etc. 8. So these have a value of 1, 2, 4, and 8. And if you add up 1, 2, 4, and 8, 1 and 2 is 3, 4 is 7, 8 is 15. So then the next part of the logic here is we're going to latch that value. So we have here an AND gate and a set reset memory toggle. These are being driven by this timer sensor, and so he is active for a ½ second every 10 seconds. And when he's active, he runs through a NOT gate and resets, or I'm sorry, yeah, when he's active, he runs into, yep, I'm trying to remember how this works. When he's active, he runs into here and hits the reset on all these gates. At the same time, we AND the signal, and we run a buffer and a timer gate here so that we make those active long enough to make sure that the latches actually latch the values. So this happens on the reset, and then we latch the values, and then both of these go dormant. So that once every 10 seconds, you latch one of the random values that you just generated with the shinebugs up there, right? So this time we have a 2. Next time we come around here, we clear it, we latch it again, and now we have 4 and 1 is 5. Okay? So this is the values, and then these are just inverters. So these are the reverse of the values. So this time we latched 15, right? And so all the inverters, the inverse of those is all 0. All right? So this time we latched a 2. So the only one that's on is a 2, but on the negative side, the only one that's off is a 2. This ribbon down here then, all the way across here, is a 4-bit, which is what this is, to 16 demultiplexer. So we take those 4 multiplexed bits that we generated up here, we take the inverse of those, and we have a ribbon with the positive values and a ribbon with the negative values. All right? Forget the Tetris blocks down here. We'll get to that in a minute. So here you can see I tried to lay this out really logically. This system right here is basically just a 4 input AND gate. So if we bring up the the logic overlay. Start sandbox mode. Bring up the logic overlay and look at this. Then what we can see is, and now I've got a here, let's get this so in here. You have this is all the negatives. The negatives run through the bridges, and the positives come right off the positive side. So if we look at this, this is going to be bit 1, bit 2, bit 2, bit 3, bit 4. This is bit 1, bit 2, bit 3, bit 4. So they're laid out so that you can very easily see the ones that are on and the ones that are off in order to make this state true. All right. The fact that they now show you the reds and greens in these bus readers and writers is really slick. Okay, so at the moment, this is the one that's on, and he's 8 and 1 is 9. Okay, so we're just really, take all 4 of these bits, and them together, figure out which ones are the negative and the positive, right? So if these are the ones that are on, if these are the ones that are on, and they're all ANDed together, then that's the output that you get. Because we now have 16 of those, 0 to 15, we have to write them out on 4 ribbons. All right, so 0, 1, 2, 3 are on this ribbon, 4, 5, 6, 7 are on this ribbon, 8, 9, 10, 11, and 12, 13, 14, 15 are on the 4th ribbon. All right, so you'll see that here's 15. All 4 bits have to be on in order for the 15 count to be on. All right, so that's your 4-bit to 16-bit demultiplexer. It takes the multiplexed of these bits and only turns on one of these 16. Only one of these will ever be on at a time. All right, and when you see the latch go through its toggle, you'll see 0 goes on and then 0 goes back off. So 0 goes on whenever we're in the reset state, and then a new value goes on whenever we hit the in this case it's 11. So I have to go back over here, and here's 11 is on. Yes, I can do that in my sleep. That's what I do for a living. So then the third part of the logic, this was an earlier version. This is where Ruby's living in here and keeping the lights on for us. This was an earlier version of the random number generator, and I abandoned it for a much simpler system when I realized all I really had to do was give you a fair 0 and 1 for each bit. Right? In the long term, you'd have to manage these critters and make sure they stayed alive, and you only had one in each, pair of rooms. That take a little bit more shenanigans, but at the moment we aren't doing that. So now you've got these 4 ribbons that are values 0 through 15, and only one of any of these 16 lines will be on at a time. So, turns out, conveniently to this, which is what made me think of doing this in the first place, there's only 15 Tetris blocks, and of course 0, which is, nothing is on. So I tried to lay them out in a somewhat logical manner. The 2x2, the 2 vertical lines, there's 1, 2, 3, 4, 5, 6, 7, 8 L's, or J's, depending on, and then 4 T's rotated in each of the 4 different directions. So then what I did, in order to be able to make this nice 16 pixel grid, is I looked at every one of the 16 pixels, treating this one as a pixel, this one is a pixel, this one is a pixel, this one is a pixel, and this one is a pixel. So in this case, let's take a simple case here. The simplest cases are these 2 right here, numbers 0, 1, 2, and 3. So if I look at number 2, this is the only one that's going to have 4th row, 1st column. It's the only one that's going to have that on. Okay, everything else should be zeros, but that's the only one. So this is the only one of these, and these are 1, 2, and 3. So it should be number 3, bit 3 on the first ribbon is the only one that should drive this pixel. and none of these other pixels should be on. So I should only have one bus writer on the bottom row. All right, so if we go over here and look, sure enough, there's only one writer on the bottom row, and he's bit 1, and he comes over here, and he is bit number 3. Okay, so it's bit number 3 off of the first ribbon, writes to the bottom left pixel. Right, this is pixel 1 here. There's a ribbon back here. Okay, unfortunately, I didn't lay this out very cleanly, so this is row 1, this is row 2, this is row 3. I'd like to move them around, but I don't really want to redo this logic. But I wanted to give you a sense of what we're doing here. So, for instance, this is a great example, okay? So right now, I'm going to pause the game. Too slow. What was on was this number, right? So number 4 was the one, number 0, 1, 2, 3. He's the one that was on, bit 4 on the first ribbon. And so this, the right-hand column of the first row, is only lit by this one. So if we go over to the first row, the right-hand column, this is the right hand. These are bits 1, 2, 3, and 4. So the only one on that should be, if we follow it back over here, bridge, bridge, bridge. Yep, sure enough, he's bit 4 of the first row. So he's, you know, bit, output number 3, and he drives that pin. Right now they're all off because we're in a reset state. That was a little too slow, so let's get another one back on here. All right, number 6. So number 6 should be this inverted L, and it hasn't. I paused the game quick enough that it hasn't propagated. It's turned this on, but it hasn't propagated back through these columns yet. So if I unpause it for just a moment more, now you'll see them all show up. So it takes about a half a second to propagate all the way through here in order to see the next piece, just because we've got so many pieces of logic that those things have to propagate through. I don't know how many frames it takes to do that, but so here we see, yep, sure enough, we got the right piece. He's the one that's on, and that's the piece that we get. Okay, so we can look and see, yep, the first 2 in the first row, the second one in the third row, the second one in the second row, the second one in the third row, and nothing in the fourth row, right? So then the way the logic works over here is that these are just wire ORed together. So you don't really need an OR gate if once you get off of a ribbon reader. The ribbon reader here, let's bring up the logic. There we go. Unfortunately, debug doesn't give you all the overlays. I'd have to figure out how to turn those on, but I'm just doing it this way. So here you can see that the interesting thing is that, you know, only one of these is really actually on. Of these 4 coming off these 3 different ribbons, it turns out you can see it's this one right here, this green column here. Unless you're red-green colorblind, and then you can't really tell what's going on. So the third bit here, where the vertical lines of my cursor are, that's the one that's on, right? And this is probably bit 3, so you can see bit 3 is the one that's green. Now, but notice that all these connections show green. If we ran this into, you know, a couple of AND gates and then ran out here, you could do that, and it would be just as valid as doing this. But if the only logic that you're going to do is ORing things together and coming off the ribbon readers and going to something like a ribbon writer or some other logic gate, or even you're going to use that to drive another piece of automation, then you don't need the OR gates if all you're going to do is OR gates. This is what in electrical engineering will be called a wired OR. So you're driving these lines, right? And whatever's driving it is going, if there's anything that's high, if there's anything that's green, it's going to drive the whole thing green. What you can't do is then also include other logic kind of inside of here. If I was to use AND gates, or other OR gates inside of here, I have to run every one of these 4 different lines here. All 4 of these ribbon readers would have to run to their own inputs on their own OR gates, because otherwise you're going to backdrive the green signal back into something else, and you're going to screw the logic up. But if all you're going to do is order the things together and drive them downstream to the right, like I'm doing here, to the right here, then you don't need any gates. And the reason that I had left all this space out here is because I thought I needed all those OR gates, and then I realized that I didn't, and it was much simpler to do it this way. So for each of these lines that I'm driving out here, I started on the left, and I drove anything coming from the left-hand ribbon all the way across a bunch of bridges, and then I just wire-ORed up to those with the other ribbon readers off of the other 3 ribbons. So everything gets driven off of the first ribbon, and then these things get wired-ORed onto the rest of it. Right? So let's get back out of that and turn the game back on. So if we turn this turn the speed up a little bit, then you can see a little bit of a flash in between here. You know, you see some odd, slightly odd behavior before the new Tetris piece settles out. That's just because it takes things a while to propagate down the ribbons. And here that time we actually got a 0 momentarily, because all the shinebugs were on the left-hand side. So you can see them kind of move back and forth and turn the bits on and off. And then the latches only run, like I said, once every 10 seconds, the way I have the timer set up. You could make that quite a bit faster if we came in here and made this, 4 seconds or something. Then we could have a new Tetris piece every 4 seconds. So that's kind of fun. So I wanted to run through how to use these ribbon readers and writers logic the way I had used them anyway. And hopefully you guys can have some fun with that. So the thing that we found is that if I use the debug tool and I copy some of this logic, right, and then I go and I paste it somewhere, so I can paste it somewhere that's not going to screw everything up. All right, and then I do clear selection. All right, and I come back in here. For one thing, the ribbons aren't connected. Now the wires are connected, and the wires are doing all kinds of goofy things here, but the ribbons aren't connected. It doesn't reconnect the ribbon lines, so you'd have to manually reconnect the ribbons. And the other thing that we found is that everything, all of the readers, and in fact the writers will do this too, they're all bit 1. So you can't actually reproduce this logic that I've generated in here any other way. There's no way to reproduce it. The blueprints won't capture it, and the debug mode won't capture it. So while I can show you how to derive this logic, I was really hoping to be able to share individual blueprints of the shinebug random number generator, the latch, the 4 to 16 multiplexer, the Tetris logic, and you could plunk them into your base and hook them back up, but you can't do that. So I'm talking to the folks who made the blueprint mod, and if I can pull some free time, I think that we'll try and maybe work together and see whether or not we can figure out how to set the values that we've read from those things. So I also submitted a bug report to Clay and said, hey guys, we need to be able to, you have these great ribbons and readers and writers, but they don't do us any good if we can't copy and paste them, even in debug mode. That is really a bug that needs to get fixed. And oh, by the way, this thing right here where the ribbons aren't really reconnected, that's not right. That's definitely a bug in the debug logic. Because like this right here, it reconnected the individual wires, but it didn't reconnect the ribbons. So they need to fix that. All right, there's my my weekend of I spent about 8 hours, between 6 and 8 hours on this over the weekend of first weekend in March in 2020. So anyhow, hopefully you guys had a good time. Thanks for listening and watching, and hopefully you learned something.